Hello all, welcome to our YouTube channel Learn to Infinite. This is Dr. Deepalakshmi. So yesterday we have seen the video, a basic introduction about number systems. It is useful to all, and I also told it will be useful for those who are preparing for your competitive examinations as well as for the school students. So now continuing with the chapter binary to decimal. Yesterday I told about the basic conversions which are there. So the first conversion which we are going to see today is binary to decimal. So binary as a base 2, decimal as a base 10, right? So let us take a binary number 11.01 to the base 2. So whenever we are pronouncing a binary number, we should not pronounce this as 11. Many of them do this mistake. We should not pronounce this as 11 because binary number comprises only of two digits 0 and 1. So we should pronounce as 11.01 to the base 2, right? So if a question is asked this, convert this binary number to decimal number. They will not give you in the question, convert this binary number. So only by noting down this base, we should know or we should identify that this number belongs to the binary number, right? Okay. So this number, when you take this example, it comprises of the whole part and fractional part. So what is the whole part? The number which is before the decimal, right? So this is your whole part and this is my fractional part. Okay. So a binary to decimal number, when it has to be converted, it should be multiplied by 2. Okay. So coming on to the whole part. So take this LSB. So what you call it as a LSB? LSB is nothing but least significant bit. So LSB refers to least significant bit, which is the last bit. Okay, and this bit is called as the first bit is called as the MSB. So MSB refers to most significant bit, right? So now you would have an idea about what is LSB and MSB. LSB is the least significant bit and MSB is the most significant bit, right? So now we have to take, before the fractional point, we should concentrate on LSB, that is least significant bit. So this is our least significant bit multiplied by 2 power 0. And next digit multiplied by 2 power 1 and so on. If it is going to be the next number, it is 2 power 2, 2 power 3, 2 power 4 and so on, right? Okay. Now, you should know the basic points. Any number raised to the power 0 is 1. You should have studied in your previous sections or previous classes. I think so starting from 6th standard you would have known any number raised to the power 0 is equal to 1. So what is 2 power 0? It is 1. So 1 into 1 it is equal to 1. The same way 2 power 1 is 2, 2 into 1 is 2, right? So we have now arrived at the whole part. So adding on 2 plus 1 is 3. So the whole part answer is 3. So now we can concentrate on the fractional part. What is the fractional part? 0, 1. So you have to note down, whenever you are concentrating in whole part, you have to start from LSB. Okay, that is least significant bit. Whereas when you are concentrating in fractional part, you have to take from MSB. Okay, that is most significant bit. That is the difference between the whole part and fractional part. And coming again, when you are taking the whole part, you have to start from LSB, least significant bit. When you are coming to the fractional part, you have to start from MSB, that is most significant bit. So coming on to the most significant bit, so we are starting from 2 power 0, 2 power 1 for whole part, whereas in fractional part, you have to start from 2 power minus 1. So 2 power minus 1, 2 power minus 2 and so on, 2 power minus 3, 2 power minus 4 and so on, okay. So any number multiplied by 0 is 0, so it is 0, right. So 2 power minus 1, what is 2 power minus 1? So you would have, as I told you, a power 0 is equal to 1, a power minus 1 is equal to 1 by a, right? This is the formula we have. So 2 power minus 1 is nothing but 1 by 2, which is equal to 0.5. So 0.5 into 0 is 0. What is 2 power minus 2? It is 1 by 4. 2 power minus 2 is 1 by 2 power 2, which is equal to 1 by 4, which is equal to 0.25, right? So 0.25 into 1 is Again 0.25. So summing up, you will be getting 0.25. So what will be our final answer for 11.01 to the base 2? When it is converted to decimal, your answer will be 3.25. First is your whole part, that is 3, and next is your fractional part, 0.25 to the base 10. This is my answer, right? So I think you would have a clear idea in converting the binary number to the decimal number. So some questions they will be asking only the whole part, some questions they will be asking only the fractional part. So to make a clear idea of you, I have given an example which involves both whole part as well as fractional part. So what you have to make note is, for whole part you have to start from the LSB, and for the fractional part you have to start from the MSB. Since you are converting binary to decimal, multiply by the base for binary number is 2, right? So next conversion, we will move on to decimal to binary. So right, we'll move on to the second conversion, decimal to binary. So same way we will take the whole part and fractional part, 16.12. So here the whole part is 16 and fractional part is 12. So as I told before, we can identify the number as decimal or binary by its base. So this is identified as a decimal number by its base. Okay. So we need to convert this decimal number to a binary number. So we need to split up into whole part and fractional part. So here what we need to do is, the whole part need to be divided by 2, right? So what is your whole part? It is 16. So when you are dividing by 2, it is 8 and the remainder is 0. Again, on further division, it is 4, remainder is 0. It is 2, remainder is 0, and it is 1, remainder is 0, right? So this is for the whole part. When you are writing the answer, you have to be very careful. Have to write from bottom to top and not top to bottom. So the whole part will be 1, 1, 2, 3, 4. So it will be 4 zeros, right? Now moving on to the fractional part, it is 0.12 into 2. Now we are going to multiply the fractional part by its base, whereas the whole part must be divided by its base. This is the basic principle of conversion from decimal to binary. So when multiplying by 2, you will be getting the answer as 4 to 0.24. Okay. So what will be the integral part? The integral part will be 0. This is your integral part, 0. Right? Now again take down the fractional part here, 0.24. Again multiply by 2, you will be getting 8 for 0.48. So again the integral part is going to be 0. Now taking the fractional part and multiplying by 2, you can multiply till 4 digits or 3 digits. Okay. So you will be getting the answer as 16, 9, 0.96. So 0. Again 0.96 into 2, which is 12, 1.92. So what is the integral factor? Your integral factor is 1. Clear? So this is going to be the integral factor. So when you are writing the answer for fractional part, you have to go from top to bottom and not bottom to top. Okay? So this you have to be very careful. When you are dealing with your whole part and dividing, the answer must be written from bottom to top. Whereas when you are dealing with your fractional part and multiplying, the answer must be in top to bottom. So your final answer is the whole part answer 10000 point. Okay, from top to bottom when you write it is 0001 to the base 2. So the decimal number 16.12's binary conversion answer is 10000.0001 to the base 2. Hope you would have understood this. So moving on to the next conversion, binary to octal, octal to binary. Right? So previously we have seen how to convert a binary number to decimal and decimal to binary number. So now we will be seeing how to convert a binary to octal, octal to binary. So I'll be teaching you a very easiest way how to convert. Okay? Usually octal is represented as 3 bits for a binary number. So as you all know, the octal number starts from 0 to 7, right? So it is 0, 1, 2, 3, 4, 5, 6, 7. So the binary bit is represented in form of octal number is 000, it is 01, 001, 010, 011, 100, 101, 110, 111. So this is the binary representation of an octal number starting from 0 to 7. So you know, like you'll be seeing now the 001 has come out, 010, 011 now it has come. It is just nothing but adding 1 to each and every number. So I'll be just telling you in short how to do the binary addition. I think everyone would be familiar. So the binary addition will be concentrating like this: 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, again 1 plus 1 is 1 0 and it is not 2. So this is what binary addition is. Okay. So applying this formula to this, so when you see 0 plus 1, it will be 0 0 1. Again plus 1, 1 plus 1 it is 1 0, so 1 0. Again adding 1 to it, 0 plus 1 it is 1, 1 1. Adding 1 to it, 1 plus 1, 1 0. Again 1 plus 1, 1 0, 1 plus 0, 1. Again adding 1 to it, it is 1 0 1. Adding 1 to it, 1 plus 1 it is 1 0, 1 1. Adding 1 to it, it is triple 1. Okay. So using this formula, we are getting this 0 to 7 octal representation. So now we will see how to convert a binary number to octal number. Okay. So take any number, binary number 100100101. Okay, 0.1010 to the base 2. So I need to convert this binary number to octal number. So what you have to do? First take the whole part first. So your whole part will be 100101001. So previously what we have told, we have to start from the LSB, least significant bit. So which is your least significant bit? This is our least significant bit. Split it up into 3 bits because it is a 3-bit representation. Okay, split it up into 3 bits. Starting from the LSB. So now we can see there is only 2 bits available. So you can proceed with one more 0, no problem. Because 01 is equivalent to 1, right? Okay. So we have split it into 3 bits. So see the corresponding octal number. What is 010? So 010 is 2. Again 010 is 2. What is 101? 101 is 5. So double 2, 5. Now coming on to the fractional part, it is 1010. So as I told you, fractional number you have to start from your MSB and not from your LSB. Okay. So split it into 3 bits, it is 0. Here you are having only 1 bit. So succeed with 2 more bits, it is again 0. So what is 101? 101 is again 5 and this is 0. So your final answer will be a binary to octal number is nothing but 225.50 to the base 8. So don't forget the base. Okay. So this is the shortest and easiest conversion of converting a binary number to an octal number. Fine. So the next conversion is how to convert an octal number to binary number. So take any octal number, say 653.25 to the base 8. So converting this octal number to a binary number. So what is, you can take like this. First take the whole part, 653. So what is the corresponding binary number for 3? It is 011, right? The corresponding binary number for 5, it is 101. The corresponding binary number for 6, it is 110. So seems to be easy, right? Okay. Now coming on to the fractional number, it is 25. So for 5 it is again 101. For 2 it is 010. So writing the answer as whole part and fractional part. So your final answer will be 110, 101, 011.010, to the base 2. So the octal conversion of 653.25 to the binary number is 110101 011.010101 to the base 2. So hope you would have understood how to convert a binary number to octal and octal to binary. So in our example, I have concentrated both in whole number as well as fractional part. Okay. Suppose in your question they are asking only fractional part, do only the fractional part, whole number should be 0. Right. So hope you would have understood this part. So now let's move on to the next conversion. Binary to hexa, hexa to binary. So hexadecimal as the base 16, it starts from 0 to 9 and then A to F. So that is what I have written here, 0 to 9 and then A to F. So the binary representation of an hexadecimal is in the form of 4 bits. So previously we saw the binary representation of an octal number is in the form of 3 bits, and here an hexadecimal number it is in the form of 4 bits. So we already seen in the last conversion how it is being added, where 0 plus 0 is equal to 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1, 0. The same way, when you are adding 1 to it, 1 to each and every part, you will be getting the subsequent number, right? So as we see here, plus 1 is 1, again plus 1, 1, 0, plus 1, it is double 1, again plus 1, it is 1 plus 1, 1, 0, 1 plus 1, 1, 0, 1, 0. So the same way when you are adding 1 to it, you will be iterating till double 1, double 1, right? So we will straight away move on to the conversion of a binary number to an hexadecimal number. So for binary to octal, we have splitted the number into 3 bits. For hexadecimal number, yes, it's obviously 4 bits because it is represented as 4 bits, right? So take the fractional number separately and whole number separately. So first moving on to the whole number, it is 1 0 1 1 1 1 0 1 0 1 1. So we have to start with LSB. So we are starting with LSB split up into 4 bits. So 4 bits is 1 0 1 1, again 1 1 0 1 0 1. So 1 bit is missing here. So what we should do? Correct. We have to proceed with the 0. So it is 0 1 0 1. So see the corresponding hexadecimal number over here. What is 0 1 0 1? So 0 1 0 1 stands for 5, right? Okay. Next is 1 1 1 0. So 1 1 1 0 is E. Can you see here? Right. 1 1 1 0 is for E. So this is E. Again 1 0 1 1. So 1 0 1 1 stands for B. So our whole part answer is 5EB. Now moving on to the fractional part. So fractional part it is 1 0 0 1 0 1 0 1 1, right? So for fractional part you have to start with, yes, good, MSB. So we are starting with MSB, not LSB, right? So split it up into 4 digits. It is 0 1 0 1 1 1. So 2 bits are missing here. So we are succeeding it by again 2 zeros. So what is 1 0 0 1? 1 0 0 1 is 9. Next is 0 1 0 1. 0 1 0 1 stands for 5. And 1 1 0 0. 1 1 0 0 stands for C. Right? So after doing this, you have to write it properly based upon the whole part and fractional part. Our whole part answer is 5EB point. Our fractional part answer is 95C with the base 16. So hope you understood how to convert binary to hexadecimal number. Now we will see the vice versa, how to convert an hexadecimal number to binary number. It's really an easy task because we already know what are all the hexadecimal numbers and corresponding binary numbers. We have written it over here, and you also know how we have derived it by simple binary addition, just adding 1 to the consecutive numbers, right? Okay, taking the whole part here, the whole part is B and D. Correct? So what is the binary representation for D? It is 1 1 0 1. The binary representation for B is 1 0 1 1. Correct? Now moving on to the fractional part, it is EF3. So the corresponding binary number for 3 is 0 0 1 1, and for F it is 1 1 1 1. For E it is 1 1 0. Correct? So writing the answer, so you have to be very careful in writing it because many students will solve it correctly, but when writing you are missing 1 0 or 1 1, definitely your answer is going to be wrong. Okay, so first write the whole part. It is 1 0 1 1 1 1 0 1 point. The fractional part is 1 1 0 1 1 1 1 0 1 1 to the base 2. Isn't it easy? So this is how we are converting binary to hexadecimal number and hexadecimal to binary number, right? So the basic difference between octal and hexadecimal towards binary conversion is, for an octal number we have to split it up into 3 bits. For an hexadecimal number you have to split it up into 4 bits. The consequent bits are got by adding 1 to it. So we have seen the simple binary addition. The basic binary addition principle you have to know, 1 plus 1 is 1 0 and it is not 2, right? So overall conversions of a binary number we have seen. In next video, I would like to post how to remember, because many one knows, okay ma'am, I know when multiplying we should do this, when dividing we should do this, but any shortcut to remember all these methods in a single form? Yes, in next video we will be seeing a table, single table. So if you are fully known to the table, definitely you can convert any form of numbers. Any conversion is possible by looking at that particular table. So I'll come with the table in the next video and we'll see the left-out conversions. Till then, it's Dr. Deepalakshmi signing off. Have a good day.